Hello everyone. Okay, so the next concept is we have already studied the stiffness of the fixed beam. So we know that in a continuous beam, the end beams, if they are fixed, and the intermediate beams are simply supported, so the complete beam will be treated like a fixed support only. That's why we have taken the distribution factor as WEI, that is, sorry, 4EI by L. Okay, so stiffness of a fixed beam is 4EI by L, and the carryover moment at such end exist, and the carryover moment would be half of it. Okay, so carryover moment would exist, and it would be half of the existing moment. Now, the stiffness. Now, if in case it's a simply support beam, so stiffness of the simply support beam is given by 3EI by L. Okay, so and the carryover moment at such end is 0. So if it is a simply support, and more specifically if it is a simply support at the end here, only this end, so first thing is the distribution factor for this would be 3EI by L in the distribution table. And the next thing is the carryover moment at this joint would be 0 because no moment exists in the simply support beam, simply support end. Okay. All right. So let us solve a problem, simple problem wherein it is simply supported. Okay. Now you can see here, analyze the continuous beam by moment distribution method. And in case in the exam also, if they don't ask draw bending moment diagram, it is understood that you should draw bending moment diagram. Okay, so you can see here, this is end A, B, C. So end A is fixed, B and C are simply supported. So AB is a span of 8 meter and carrying a UDL of 20 kilonewton meter and having the value 2I. Next, BC is 4 meter span and 60 kilonewton load is loaded exactly at the center and it has only I here. Okay, so it's a simple beam, only two span beam. So B and C are simply supported. So now, as usual, first find the fixed end moments. The fixed end moments AB for AB span it is minus WL square by 12. Then for BA it is plus WL square by 12. Next, BC it is minus WL by 8. CB is plus WL by 8. Okay. Now, joint C is a simply support, but B is a continuous. Okay, now you can see here, A is fixed. Okay, joint C is the end, simply support end, because at this point the beam ends. Okay, but B, you can see here, B, it is a roller support. It is having a roller support, it is having a simply support, but because it is placed in the center, it is an intermediate beam of AB and BC. That's why this will be treated like a fixed beam only. Okay, so now A is a fixed support, B is also fixed support because it is at the center, whereas only C is at the end. The beam ends at C. So this is treated like a simply support end. Okay. So now, where the matter of difference occurs is in the distribution factor. Now, as usual, see here, and so we'll take only joint B. So joint B, BA, BC. Okay, at joint B, this BA and BC. Then, and C also. Now, why we take the C is because at C, there is one member connecting and it is a simply support end. So always we'll take the simply support end also when you're considering the distribution factor because it is changes there. You can see here B, joint B, it has BA, BC. So it has BA, BC and C has CB. Okay. Next. Then stiffness. Now stiffness BA. Okay, so first stiffness of BA is at this joint there is a fixed support. So fixed support is 4E I by L. So I here is 2I divided by L. Similarly, BC. Okay, now you can see here in BC, C support. C support is a simply support, first thing, and it is the last support. Okay, so that's why at C we'll take it as 3EI by L. So at BC, in BC, so this is 3EI by L. So it is now 0.75. Okay, next add both of these. So when you add both of these, it is 1.75 EI. Then distribution factor is summation k by summation k. So it is k is 1 divided by 1.75, 7.7, then 0.75 divided by 1.75. Okay, you get these two values. Okay, next is in joint C. Okay, in joint C, this is a simply support. Okay, next is CB. So this member is CB, but B is a continuous support. So B is a continuous support and adjacent to that is a fixed support. So that's why B will be treated like a fixed support. So all the intermediate supports, no matter if they, even if they are simply support, they will be treated like a fixed support. So that's why in CB, the K value is 4 EI by L. So 4 by 4 is 1. So 1 by 1 is 1. Okay. So this is important here, understanding this. Okay. Now, so when you add both the distribution factors of members, you should get the sum of all the answers should be equal to 1. Okay. All right. Next is the moment distribution table. Okay. So in moment distribution table, first as it is joint, member, distribution factor, and fixed end moments. Okay. First joint A, B, C. Okay. Same. You have to draw it like this only. Joint A, B, C. Then members A, B, B, A, B, C, C, B. Same thing you have to draw here. A, B, B, A. So split this B into 2. So it connects B also, it connects BC also. Then is CB. Okay. Then distribution factor. So distribution factor is at AB there is no distribution factor. Okay. But in BA it is 0.57, in BC it is 0.43. And in CB, you've already calculated this distribution factor, that is 1. Then find the, write the fixed end moments. We have already calculated the fixed end moments here. It's minus 106 plus 106 plus 30, this is minus 30 and this is plus 30. Minus 30 and plus 30. Okay, once you write the distribution table, now this is a step which is carried out when the beam always has the simply support end, whether it is to the right or to the left. The end support, especially this end support, if there is a simply support, then always you have to balance that first. Only balance that particular joint. So if you want to balance, now see here, balance or balancing the simply support joint. So here simply support is at C. Okay, so here simply support is at C. Now because simply support is at C here at this portion, so it is, if it is plus 30, then change the sign and write minus 30. Okay, so no matter whatever is the number here, just change the sign, because what you want to do is, ultimately we know that at the simply support end, the moment would be 0. So we have to make this moment 0. Okay, so to make this moment 0, what we'll do is, so if it's plus 30, just change the sign, write minus 30. Okay, so eventually when you add this, it becomes 0. So now, so this minus 30, okay, now all these are at B is a intermediate end. Now because B is an intermediate end and it's also treated like a fixed end, so from C, half of the moment gets distributed here. So minus 30 becomes minus 15. Okay, so minus 30 is minus 15 here. So half of the moment gets carried over here. So this is the carryover moment. So it gets carried only from CB to BC. That's all. The adjacent support to C is B. So only in the BC span it will get distributed. Okay, then once you write this carryover moment, next is again balancing. So at this joint you have to balance. Now at this joint how to balance is again same. Complete you have to take now. Now is the actual balancing what you have done before you should be done. Now only this is carried over. So you have made the simply support end 0. That's all. And you've got the carryover moments here. Now the next step is you have to carry out all the moments. You have to consider all the moments at B. Okay, so all the moments at joint B is say 106.67 minus 30 minus 15. You have to take 1, 2, and 3. I've put tick marks here. So you have to consider 1, 2, and 3. Now is the actual iterations and balancing and carryovers you have to start. Okay. So then this would be, now when you add this, it was 61.67 into 0.57. So it is 35. Okay. So here 106 minus 30 minus 15 is plus 61.67. Okay. All when you add this 3, it is plus. But what you have to do when you're balancing at joint B, you have to change the sign. So because the answer is plus, just change this to minus and minus. Okay, so plus answer becomes now minus. Now whatever answer you've got, 61.67 into 0.57, that is 35.15. Write it here. Similarly, 61.67 into 0.43 is 26.51. Okay, so you have balanced the joint B. Okay, now you have to again, once balancing is done, then you have to carry over. Okay, so carry over moment is nothing but again from minus 35.15. Okay, see here from BA it gets carry over to AB because AB is a fixed support, right? So from here it gets half of the moment. So minus 35.15, half of that is 17.57. That's all. See here again we have this 26.51. Again this cannot be carry over moment to joint C because joint C we have already made it 0 in the beginning only. We know that the moment at the simply support end would always be 0. That's why we have made this completely 0 here only, and we have taken all the moments. The moments created by this end is already carried forward to the adjacent side. Okay, so again this also you should leave it as it is. You should not again carry over. So you should see that at this joint it should be 0. Then only from 35.15, that is from BA, gets carry over to AB. That's all. Okay. All right. Once you carry over, next, there's no more iterations. This is the final step because you cannot further balance it. So because you cannot further balance it, I have to stop here and then you have to find the final moments. Okay. So the final moments are, so you can see here. So this is add all this column 106 minus 106 minus 17. So it is minus 124. Then this is 106.67 minus 35.15. So it is 71.52. Answer is positive. Similarly, this portion minus 30, minus 15, then minus 26.51. So when you add this, it is minus 71.51. So this is answer is 0. So the check for this is the at joint B, because it's a beam, at joint B, the moment should be equal and opposite. So here the moment is, so if this is plus, this is minus. Okay, so these are the final moments. Okay, ultimately you have to draw the bending moment diagram. So when you're drawing the bending moment diagram, so it is first AB. AB is a UDL, so it is WL square by 8. So WL square by 8 is 160. So draw a parabolic curve. Next, span BC is WL by 4. So WL by 4 is 60 kilonewton. Okay. Next, you have to draw these moments here. So first is 1 minus 124. So minus 124 at A. Then at B it is plus and minus. So it is 71.51. Mark here. Okay, it should be again draw to the scale such that it should be little less. So 124 is here and this is 71.51. Okay, next at C it is 0. So mark this. So ultimately mark all the points here. So whatever lies between like this, within these, okay, hatch this portion. These are all 1, 2 are negative bending moments, and whatever lies outside this line, okay, or whatever lies outside this line are nothing but the positive bending moment. Okay. All right. So that's all for today. Thank you.